So in this video we're going to talk about organic chemistry. So which part of organic chemistry? We're going to talk about the hydrocarbons, which is the alkanes. Alkanes, we're going to use the nomenclature of alkanes, how to name alkanes, what you're going to do in naming of alkanes, the procedure you're going to follow when naming alkanes. So let's start. First, what are alkanes? Let me start explaining something for you. The alkanes are subdivided into two classes known as stretching alkanes and branching alkanes. In the stretching alkanes, no carbon atom is bonded to more than two other carbon atoms, while in the branching alkanes, there is at least one carbon atom that is bonded to 3 or 4 others. Stretching alkanes are named by counting the number of carbon atom and adding the family suffix ANA. So anywhere you hear or anywhere you see in organic chemistry a compound ending with ANA, we definitely call that alkanes. So let's start naming alkane. So first, what is the general structural formula of alkanes? The general structural formula of alkanes, like the general molecular structure of alkanes, is CnH2n plus 2. So this is the general formula of alkanes. So wherever you see CnH2n plus 2, you're talking about the general formula of alkanes. So the first member of the alkane family is what we call the methane. So in this video, we're going to talk about the first 10 members of alkanes in the functional group, which is the methane, the ethane, the propane, the butane, the pentane, the hexane, heptane, octane, nonane, and decane. So let's start. So our first member here is methane, and methane has general formula of CnH2n plus 2. Like this is the general structural formula of alkanes, but if you're talking about methane, you're not saying CH4. So in methane, the carbon atom is equivalent to 1. So since the carbon atom is equivalent to 1, what next? Now let's calculate. Since carbon atom is equivalent to 1, so in methane, N is equals to 1. So since N is equals to 1, we now say Cn H2n plus 2. So N there is 1. So carbon will definitely become 1. So H there is 2. So this is 2 multiplied by 1 plus 2. So 2 multiplied by 1 plus 2 equals to CH. 2 times 1 is 2 plus 2. So now we now have CH. 2 plus 2 is what? 4. So the general formula of methane is CH4, while the structural formula is CH4. So let's talk about the next. So our next is ethane. So what of ethane? Ethane has N equals to 2. So since N is equals to 2, from our formula CnH2n plus 2, so we now have C, carbon becomes 2, H, 2 times 2 plus 2. So therefore we now have C2H. 2 times 2 is 4 plus 2. So therefore we now have C2H6. So when you're talking about the structural formula of ethane, so structural formula of ethane is C2H6. So if you want to like draw the staggered formula, so you can just do something like this: CH3. So anyway, just see something like this or this, we definitely call it ethane. So I'm going to talk about the first 10. So the first 10 is methane, ethane. So next is propane. So next is butane. So another one is hexane. Another one is heptane. Another one is octane. Another one is nonane. Another one is decane. So first, for this introduction, I will first and for this introduction of alkane, nomenclature of alkane, I'll first tell you we're going to practice on how to name the first 10 carbon atoms of alkanes. So when you talk about methane, from our formula, our general formula, which is CnH2n plus 2. So in this formula, I just wrote now CnH2n plus 2. In this formula, methane N is equals to 1. So in ethane, N is equals to 2. In propane, N is equals to 3. In butane, N is equals to 4. Pentane before hexane. So pentane usually comes first before this hexane. So note that first is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So in butane we have N equals to 4. In pentane we have N equals to 5. Pentane N is equals to 5. In hexane we have N equals to 6. In heptane we have N equals to 7. In octane we have N equals to 8. In nonane we have N equals to 9. And in decane we have N equals to 10. So anywhere you see all these formulas, anywhere you just see all these formula, N equals to 1, N equals to 2, N equals to 3. So whenever our carbon atom here is 3, 4, 5, or any number ranging from 1 to 10, so just know it lies between methane and decane. So in methane, N is equals to 1. So if N is equals to 1, so we have our structural formula to be CH4. I've showed you how to calculate this. So out of if N is equals to 4, so when N is equals to 4, we have butane. So when N is equals to 4, so we have N which is 4. So when N is equals to 4, carbon automatically becomes 4. So H2 times 4 will now become plus 2. So whenever we see this, definitely we are talking about butane. So what about pentane? How are we going to draw the structural formula of pentane? So in pentane we have CnH H2n plus 2. So N is equals to 5 in pentane. Since N is equals to 5 in pentane, so what we have now is C5H2 times 5 plus 2. So C5H2 times 5 is 10 plus 2. So we have 10 plus 2. So C5H12. So whenever we see this, we are talking about pentane. So what about hexane? So hexane, whenever we see N equals to 6, so you know how to do the rest. So now I've teach you how to do it, so I'll just go straight to the point and start writing it. So in hexane we now have 6H14. So what about heptane? So we are going to do heptane. So if you end up doing a heptane, N will be equals to 7. So N will now become C7H16. So if you go for octane, N is equals to 8 in octane. So you end up getting H818. So if you for decane, for nonane, you have N equals to 9. So you end up getting H9H20. So if you now do for decane, which I'm going to do, N is equals to 10. So N being equals to 10, we now have 2N plus 2. So N equals to 10, we now have carbon will become 10 since N is 10. H 2 times 10, we now have 20 plus 2. So therefore this will become C10H22. So this is what we call decane. So let me introduce you to primary carbon, secondary carbon, tertiary carbon, and quaternary carbon. So when you talk about primary carbon, what comes into your mind? So a primary carbon has a formula of CH, H, and H. So what makes this to be a primary carbon? What makes this to be a primary carbon is that it is only attached to one different group. You see, this is an alkyl group. So whenever you see R in organic chemistry, we are talking about alkyl. So repeat after me: alkyl group, alkyl group. So whenever you see R, we are talking about alkyl group. So this is a primary carbon. This is a primary carbon because it is only attached to one different group, which is this alkyl group. So when it's attached to two different group, so what are we going to call it? When it's attached to two different group, so we are going to end up calling it what? A secondary carbon. So a secondary carbon is a carbon which is attached to two different group. A primary carbon is a carbon which is attached to only what? One different group and have 3 hydrogen atom. A secondary carbon is a carbon which is attached to two different group and has only 2 hydrogen atom. A tertiary carbon is a carbon which is attached to 3 different group and has only hydrogen atom. So I decided to call this one arrow prime, arrow prime prime, arrow prime 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 prime, indicating that all these 3 different group, all these alkyl group are 3 different groups. So alkyl group have the same molecular formula of alkane, but the only difference is it has a subtracted hydrogen. Look what I mean. Alkyl group has general formula of CnH2n. Instead of +2, which is in alkyl, we now have what? +1. So alkyl group has deficient of hydrogen of -1. So when you're talking about alkyl group is the same thing as alkane, but when you remove 1 hydrogen atom from an alkane, we're talking about alkyl group. Don't worry if you don't understand that, I'm coming to that. So calm down, let's focus on our main purpose of naming of alkanes. So what about quaternary carbon? So quaternary carbon is a carbon which attaches itself to 3 different groups. So 3 different group we know here is 4 different alkyl groups. When I'm talking about quaternary carbon, quaternary carbon is a carbon which is attached to 4 different group. So 4 different groups. Since there are 4 different groups, I'll call this arrow prime, arrow prime prime, arrow prime prime prime, arrow prime 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 prime. So meaning that all these 4 groups are definitely different group. They are all different. None of them is the same. They are all different, meaning that maybe this one can be a methyl group, this one can decide to be an ethyl group, so anything. So when you talk about quaternary carbon, we generally called a carbon which is attached to 4 different groups. So when a carbon is attached to 4 different groups, we call this a quaternary carbon or a chiral carbon. A chiral carbon. So a chiral carbon is a carbon which is attached to 4 different groups. So you eventually see this chiral carbon when I talk about biochemistry. So when you're studying biochemistry, you see how this chiral carbon functions very well, especially in proteins. Proteins usually focus on these chiral carbons. So chiral carbons are carbons which is attached to 4 different groups. So chiral carbons are carbons which is attached to what? 4 different groups. So let's the alkyl group. Let's talk about the alkyl group so you understand when I'm talking about naming of alkyl group, naming of compound. You understand what I'm talking about in alkyl group. So alkyl group has a reduction of hydrogen by 1. So the general formula of alkyl group is CnH2n plus 1. Remember in alkanes we have CnH2n plus 2 as our general molecular formula of alkanes, but in alkyl group we now have this as our nomenclature of our alkyl group. So what is the first member of the alkyl group? The first member of alkyl group is called what? Methyl. You know, in In alkane we call it what? Methane. So just the secret there is just write met. If it's an alkane, you end it with what? ANA. If that is an alkane, you end it with what? ENA. But now it is an alkyl group. So alkyl group end with what? YL. So anyway you see YL, you're talking about what? An alkyl group. So you just write met, then you now add this YL. So anyway you see this, you're talking about what? Methyl, the alkyl group. So you just write YL. So methyl. So what is our next member there? Our next member, we have methyl, we have ethyl, we have butyl, we have pentyl, we have methyl, ethyl. But before this butyl, we have propyl. So the secret is in methane, just remove that ANE and add YL. So in naming of alkyl group, just go back to the nomenclature of alkanes, which is methane, ethane, propane, butane. Just anywhere you see that compound ending with ANE, just replace it with what? YL. As you can see in octane, we have ANE. So to name this as an alkyl group, we now call it what? Octyl. So this is just the secret of nomenclature of alkyl group. So let's go back to nomenclature of alkanes. Nomenclature of alkanes. So what of if we have something like this? Okay, what of if we have something like this and we are asked to name this compound? So how are we going to name this compound? Where are we going to start in the nomenclature of this compound? What are we going to do in order for us to name this compound very well, in order to avoid mistake? So the first thing you have to do for me is first identify the longest continuous chain, which is the parent chain. What is the unbranched chain there? So my longest chain, we're going to see how we're going to count our longest chain. So let's start. So if I should count this by if I should start from here in this direction, so I have 1 2 3 4 5. So is this my longest chain? So let's start from here. 1, okay, let me use red. 1 2 3 4 5. You see, both of them are 5 5 5 5. If I also decide to start from here, 1 2 3 4 5, both of them are the same. 1 2 3 4. If I should count like this, I will have 4, but if I should count like this, I will have 5. So meaning that any direction that I follow, I will still end up getting the same 5. So therefore, our longest chain here, our parent chain, is what? Which compound in alkane in which the carbon atom N is equals to 5? So the compound in which N is equals to 5 is pentane. So our parent's name is pentane. So let's talk about the alkyl group now. So our problem here is now the alkyl group. So first, in naming this compound, will I start from the left or will I start from the right? So some people usually say, yeah, you start from the right. Some people usually say, yeah, you start from the left. So in naming of alkyl group, in naming of alkane, naming of organic compounds, you can definitely start from the right, you can definitely start from the left. So you can start in any direction, but the problem is, make sure in any dimension or direction you are starting from, that your compound must have, your alkyl group, your substituents must have the lowest possible number. So lowest possible number. Yep. So as we go on in our future lectures, you're going to understand what I meant by your lowest possible number. So if it starts from here, 1, 2, 3, you see my carbon atom having the substituents is 3. So if I start from here, 1, 2, 3, so my carbon atom having the substituents is also what? 3. So meaning that in this compound I can definitely start from the left and I can definitely start from the right. So anywhere you start in naming this compound, you are definitely correct. So next rule we're going to look at is I have two substituents, which is I have the ethyl and I also have what? Methyl. So since I have ethyl and I also have methyl, which one should come first? Is it methyl or ethyl? So the truth about this is your first you should name it in alphabetical order. So methyl and ethyl. Methyl, I have methyl, I have ethyl. So which one comes first in alphabetical order? Is it the M or the E? So in alphabetical order, the first member there that comes first, the first substance that comes first is E. So E comes before M in alphabetical order. So therefore, in naming of this compound, ethyl will come before the words the methyl. So note that. So some people is confused on how I end up having this CH2 CH3. So I'll explain how I have this CH2 CH3. So let me make some space. So in this CH2 CH3, so you know our methyl has general formula of CH3, but in our alkane we have CH4. So when I'm talking about alkyl group, I'm talking about removing of what? One hydrogen atom. So alkane, which is methane here, has CH4, while our alkyl has CH3. So reduction of one hydrogen atom will give us the corresponding alkyl group. So and why in naming of the alkyl group, just anyone that have reduction of hydrogen atom by 1, as you can see in methane I have removal of one hydrogen atom which changes from CH4 to CH3. So instead of calling this methane, I will now call it what? Methyl. So what about how this CH2 CH3 come from? So you know alkyl group, which is especially ethyl has CH2 CH5. You know why? Which is ethyl, why our corresponding alkane, which is ethane, has C2H6. So since this is our alkane, which is ethane, C2H6, so our corresponding alkyl group, which is what? Ethyl, by removing ANE and putting YL, we now call it what? Ethyl, and this is what? Ethane. So I just remove this and substitute is what? YL. So this compound now is corresponding with what? The alkyl and the alkane group by removal of what? One hydrogen atom. So this compound here, which is C2H5, which is our alkyl group, which is ethyl, is the same thing as this compound CH2CH3. Wow, and this compound is this, Abi? Yep, they are the same thing. So how do we draw this compound? This is another method of drawing alkane groups. So this is I think this should be the standard structure formula. So this is another method of drawing. So don't get confused whenever you see me drawing this way. So this is the same thing as this. Let's check whether it's the same. So here I have two carbon atom, 2. So how many total carbon atom do we have here? As you can see, I have 1 and I have 2. The total carbon atom I have here is what? 2, as I have here 2. And how many hydrogen atom is here? I have hydrogen to be what? 5, and I have here what? 5. How? I have 2 here and I have 3 here. So 2 plus 3 is equivalent to what? 5. So therefore, drawing this in this manner and drawing this in this manner are definitely the same thing. So I can now decide instead of instead of drawing this in this manner, I can decide to clean this up, and I can decide to put this. We are definitely talking about the same thing. So then don't get confused whenever I'm doing all these small things. So these are just very, very simple. Once you understand the law, the magic, once you understand the law behind it, is very, 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 very simple. Trust me when I say it's very, very simple in naming of alkane. Alkane is the easiest, the most simplest compound to name when you're talking about organic chemistry. So what is our compound here? So the name of this compound is, so some people decide to start from the left, some people decide to start from the right, but me, I'm deciding to start from the right in this compound. Note that you can start both direction depending like the end product, whether you're starting from left or whether you're starting from the right. The end product is to make sure that you end up having your substituent number to have the lowest possible number. Okay, so here now I have 1, I have 2, I have 3, I have 4, I have 5. So my parents chain here is what? Pentane. So since my parents chain here is pentane, what I'm going to do now is, what's the substance I have here? So I have two substances, which is methyl and ethyl. So which one's come first? Ethyl. So ethyl, so the name of this compound will be ethyl. But how I'm going to name it? Will I just write ethyl? No, you're not going to just write ethyl. You're going to indicate the number in which this ethyl is. Why are we indicating the number where ethyl can be located? Because if you write ethyl, so if you ask me to draw ethyl methyl pentane, I can easily go and draw for you ethyl methyl pentane, but it will not be like as arranged as this one, as you can see here, because if you just write ethyl, you have not indicated the particular substituent, the particular carbon in which this ethyl is. So if you just write ethyl methyl, you are wrong, because you didn't indicate the particular carbon in the pentane or in the parent chain in which these substituents are. So when you are writing, you're expected to write the substituent in which these parent chain are located. So, and a substituent, also note that a substituent is not found at the end product. So the substituent is always found at the middle. Like, what I mean is, you can never find a substituent in this carbon atom or in this carbon atom, because whenever you find substituents there, they are definitely going to form the parent chain. Don't worry, if you don't understand, don't worry. As we proceed, I will explain what I mean. So first, let's name this compound. So in naming this compound, now we have this ethyl is in 3, so I'll write 3 ethyl, 3 methyl, what? Pentane. So the secret again behind it is, anywhere you see number alphabets, separate it with hyphen. Now let's check something. Here there is a number and here there is an alphabet. So I just went straight to the point and separate it with hyphen. There is number and there is alphabet. So I'll just keep on separating it with. But whenever you see number, you are going to just separate it with a comma sign. But whenever you see alphabet, you are not expected to separate it with any sign. As you can see here, I didn't separate this with any sign. So this, there should be no space there. So this should be clustered pentane. So there is no space there. So you see, I didn't separate these two words. I didn't separate it because there is alphabet. Whenever you see number, alphabets, separate it with hyphen. But whenever you see number, separate it with a comma sign. But whenever you see alphabet, don't separate it with any sign. They are just meant to be together. CH3, and I have CH3, and I have CH3. So how am I going to name this compound? So feel free to pause this video and go ahead and name this one. This one look more complex compared to the last example we did. So the first thing you're going to do is to locate the longest continuous chain. So our longest continuous chain is in this direction. So let's check. 1, 2, 3, 4, 5. Is it our longest chain? No. So So the answer is definitely no. That is not our longest chain. So what of 1, 2, 3, 4, 5? Is that our longest chain? No, that is not our longest chain. So our longest chain will now be, let's check, let's just see, just watch as I'm doing it. So 1, 2, 3, 4, 5, 6. So our longest chain is what? The parents chain. The unbranched chain, which is the parents chain, is what we call what? Hexane. So our parents chain is what? Hexane. So what is definitely coming to your mind? So what is coming to your mind is, before we just think that this was a substituent, but as you can see now, it's not a substituent because it is part of our parents chain. So we are not going to call this a substituent, rather we're going to call it what? Our parents chain. So where is our substituent? Remember that I said a substituent is a group or an alkyl group which is attached to the parents chain. So since our parents chain is this direction, so any compound that is absent from this direction that I just pointed now is our substituents. So how many substituents can you see? I can see 3 substituents, which is 1, 2, and 3. So we have 3 substituents. So how are we going to name this compound? So in naming this compound, first, which we have identified our substituent. So if we want to name this substituent, so we are going to name this in a way to give the substituent the lowest possible number. So if I should start from this direction here, we are not going to give it the lowest possible number, because okay, let's see it now, let's check. So I have 1, 2, 3, I have 4, I have 5, and I have 6. So in our substituents, how many substituents do we have here? 1, 2, 3. So I have 3 methyl, I have 4 methyl, and I have 2 methyl. So let's check whether if we should name it in the anti-clockwise direction. So let's check 1, 2, 3, 4, 5, 6. So let's check. So first I have 2, second I have 3, and third I have 4. So dear brothers and sisters, which side are we going to start? So definitely we are going to start from this direction because we have the lowest possible compound. But you should observe something again. What should you observe is, I have 2, I have 4, I have 3, I also have 2, I have 3, I have 4. So definitely starting from the downward side or starting from the upward side, you both are definitely correct. So when you're naming this compound, those that started from the downward side and those that started from the upward side are definitely correct. And note that you can start from the left, you can start from the right, but your main major product you should just bear in mind when you're naming alkane is that what you should just bear in mind that you should name it in a way to give the substituent the lowest possible alphabet, the lowest possible number. So now, since we have hexane as our parent chain, so what is the name of this compound? A chemistry student to say, hey, now we are in my YouTube channel, Sagacious Learners. So if you want to ask someone what is your name, don't ask that person what's your name. Just ask that person, hey guy, hey little broski, hi, what is your nomenclature? The nomenclature definitely mean what is your name. So instead of saying what is your name, a chemistry student will just say what is your nomenclature. Okay, so we have 1, 2. So this is 2, comma, because a number you have to separate. You know, I said when you have number you separate it to what? A comma sign. When you have number alphabet, you separate it to it hyphen. When you have alphabet, you're not going to separate it with any other thing. You're going to just join it together. So I have 2 because I have a methyl group attached to this compound. I have 3, so I'll call this 3. So I have 4, so I'll call this 4. Now, what is the name of this compound? So the name of this compound is 2, 3, 4 trimethyl methylhexane. So I'll separate this hyphen because it's number alphabet. So wow, complex. So how did this try came in about? How do we have this try? Why this try? What of, instead of saying 2, 3, 4 methylhexane, like why they try? So I'm going to explain something now for you. So whenever in chemistry you see 1, so you definitely call it what? Mono. So 1 is mono, 2 is what? Di, 3 is what? Tri, 4 is what? Tetra. Don't worry, I'm going to teach you naming of inorganic compound. I'm going to teach you many things in my YouTube channel, so just be ready and focus to learn. So but in organic chemistry, this one we are not going to be using it because 1 is definitely 1, so it is not necessary in organic chemistry, because whenever you write a compound without identifying mono, therefore that compound just definitely means 1. So when I mean organic compound, 1 is not necessary. So what is necessary is what? 2, 3 and 4 and 5, which is penta, 6 hexa, 7 hepta. But I'm not sure for your level, for those preparing for A level, JAMB or JUPEP, I'm not sure they're going to reach in that dimension, or even though they reach, it will be very difficult. It's rare, but I'm going to teach you, so just calm down. So we have 2 means what? Die. So anywhere you see 2, we mean die. Anywhere you see 3, we mean tri. Anywhere you see 4, we mean tetra. So note all these things. So 5 is penta. 5 is penta. So in that compound, I definitely call this tri, because I have 3 methyl group attached to this compound. So since I have 3 methyl group attached to this compound, so I'm going to invade the name. I'm going to introduce the name what? Tri. If the methyl group were 2, so students, what am I going to call this? Di. I'm going to name this as. So to name this, so I have 2 carbon atom. So I'm going to start by, let me start from here. 1, 2, 3, 4, 5. So I have 5 first. Let me start from this direction. So here is 2, 3, 4, 5, 6. So the best way to name this compound is in this direction. So the name of this compound is in this direction. The parent's name is in this direction, because if you start from the other direction or any other direction you are thinking of, you end up getting 5. So the best direction to follow is this direction I'm pointing now. So since now we now have this direction, and our parents name is 6. So what is 6? 6 is definitely called what? Hexane. So anywhere we see 6, we are talking about hexane. So now we have 6 as our parent's name, which is the hexane. What next are we going to do? So it's identify the substituents. So where are these substituents? So you should observe something. You should definitely observe something, and which is, here should be 2, not 3. So you should observe something, which is, where should I start? Should I start from the left or should I start from the right? So let's check. So in naming this compound, our main major product or our main aim is to end up that we name this, or we give the compound or the substituent the lowest possible number. So if it starts from this direction, let's check. 1, 2, 3. So here is 3. Note that. So I'll have 3. I will have 4. So I will have 3, 4 as my methyl group. So if I should start from this direction up here, I'll still end up getting the same thing, because you cannot name from this direction or this direction. Why? Is because naming from that direction is not proper. because that is not the parent's name. So the parent's name is starting from this direction. So since you have started from this direction, so to name this compound is 3 and 4. So why am I saying 3 and 4? Is because if you observe this compound, if I want to rewrite this compound, so this compound is definitely called an ethyl group, because ethyl has 2 carbon atom and 5 hydrogen atom. So therefore this is an ethyl group, and it's an ethyl because it is not acting as a substituent. So now we know that that is an ethyl. So what are we going to call this thing? We're going to call this what 3, 4. There is a comma sign because it's number to number, and there is a hyphen sign because it is now number to alphabet. What? Diethyl. Why did I use di? I use di because it is 2. I'm going to test your knowledge in this, so you're not confused or misuse it. So this is 3,4-diethyl what? Hexane. So 3,4-diethylhexane is what we call. This is N, not M. So this is 3,4-diethylhexane. So I believe from now you know how to name alkane group. Alkane, you know how to name alkane. So let's dive into the more. So from now I'll be more faster. When I'm naming now, I'll be more faster, and I'll bring more complex ones we are going to name. So I have this. So look at this question, and you are asked to name this compound. So if you want to name this compound, the first thing that should come into your mind is expanding this compound. So for you to name this compound effectively or very well without any mistake, so as a learner you're expected to first to expand the compound. So let's expand the compound. So expanding this compound, you now have CH2CH3, CH3CH2, and CH2CH3, my carbon. Look at the first thing I did was I collected these things here. In order for me to expand this compound, I collected those things. So how does that work? How did I do this thing? So you see, in this bracket means I have this compound here. I have this compound 3. So since I have this compound 3, I have to attach this compound to this 4 carbon atom. So attaching this compound to the 4 carbon atom, that is how I separated this. So they were 3. So if I should pick one, I will have remaining 2. If I should add. So this is how I expanded this compound, by picking it and invading it inside this carbon. So since I have invaded it inside this carbon, I have only 1 remaining, so which is this, and this will now bond to this carbon. So this thing bonding to this carbon, I now have hydrogen and hydrogen. So how did that hydrogen, this 2 hydrogen, this hydrogen, so for this carbon is definitely talking about these ones here. So I have this, so I have 2. So that is how I added 2 here. So now I have 2. So that is how I added 2 here. So now you can see how to expand this. First we followed from here and expand this. So in expanding structure, for example, now let me explain something for you. So if I have CH3 attached to, let me say I have 3, so to this carbon, so this definitely means this CH3 I should add it. So remaining 1. So this one is not attached to any other thing. So this one you can now use it to attach to any carbon atom you have in mind. Now this is what we also did here, but for doing this one, now this particular one, you have to have something in mind, and what you have to have in mind is You see, I have CH3 CH2, which is an ethyl group. This I have this CH3 CH2, which is an ethyl group. I held this then into the CH2. You should observe something. Here was CH2 first before CH3. Here was CH2 first before CH3, and here was also CH2 first before CH3. Like you should like take note of that if you are if I should, what of if that I did this, I added CH3 then CH2, you see that it is not complete, because if you expand this diagram you end up getting this. So, and this is definitely very wrong, because it has 5, so carbon cannot attach to 5, so is definitely wrong. So CH2 should always come first before CH3, because if I should use CH2, we now have hydrogen, and it also have another one to attach to any other group. So CH2 first before CH3. CH3 should always be at last. That is why even in this diagram we also see what CH2 before what CH3. So now we have expanded this. Let's go ahead and complete the expansion. So C, hydrogen. So this hydrogen is for this second one. Now for the third one I have hydrogen. Now I have this carbon, which is the carbon here. Since I have this carbon here, and this carbon signifies that these 3 things is attached to this carbon atom here. So what I'm going to do now is to attach these 3 things to this carbon. So what comes first? CH2 comes before CH3. What other thing? CH2 before CH3. What any other thing? CH2 before CH3. Okay, so don't confuse that. Now how are we going to name this compound? Now in naming this compound, what you have to do is to locate our parent chain. So from now, I hope now you can now do it. So I'll be now fast. So in naming this I hope you can do it, so I'll now be fast. So in naming this compound, first what I'm going to do is to identify my longest continuous chain. So my longest continuous chain is in this direction. So that is my direction of the longest continuous chain. Because if I should, okay, let's check. 1 2 3 4 5 6 7 8 9 7 8 9. If I should also go in anti-parallel, if I should also go in this direction, 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5 6 7 8 9 10. So therefore my longest chain is in this direction. So this is my longest chain, because my longest chain was 10, and 10 means what? Decaying. So anywhere you hear 10, we are definitely talking about decaying. So how many substances do I have? So in this question now, will I start from the left or will I start from the right in naming this compound? Definitely I will start from the left, correct. The right, also correct. Why? Okay, look at 1 2 3 4 5 6 7 8. If it starts from here, 1 to yellow color, 1 2 3 4 5 6 7. So the real and accurate correct one is from the left, because from the right is not correct, because my longest chain moves from the left to the right, not from the right to the left. So from my left I now have this longest continuous chain. So to name this compound, I have 3 3, and I also have I also have 8 8. So to name this compound, this will be 3, 3, comma 8 comma 8 hyphen tetraethyl decane. So this is 3388 tetraethyl decane. So after expanding this diagram here, you will end up getting this. So ending up getting this, we will have 3388 tetraethyl decane.
Hey brilliant minds, this is Sagacious Learners where science comes alive. If you're preparing for JAMB, clinical or GCA, or you're a undergraduate or medical student studying anatomy, physiology, biochemistry, physics, chemistry or biology, then I have got something special for you. I offer private and group online lessons designed to help you understand deeply and success easily. Just send me a WhatsApp message on 08163207065. Don't just study hard, study smart with Sagacious Learners. Let's grow your mind together.
Let's draw the structure. So the question is, how are we going to name this compound? How are we going to name this compound? So first, what we're going to do is to identify the longest chain, the parent chain, the longest continuous chain, the parent chain. So what is the longest chain here? So the longest chain, let's count. So the longest chain here is 1 2 3 4 5. Are we correct? The longest chain here is pentane. So what about if some people decide to start counting from here? So we have 1 2 3 4 5. So someone who counts from this direction and someone who also counts from this direction, actually they are both correct. So our parent chain here is pentane because our longest chain has 5 carbon atom. So since it has 5 carbon atom, I'm going to call this what? Pentane as the parent name. The parent chain here, the parent name here is pentane because we have 5 carbon atom here as the longest chain, so we call it pentane. Now what is our substituent? So our substituent here is the compound which is attached to the parent chain. So any compound, any alkyl group that is attached to the parent chain, we definitely call that pentane. So if a compound is attached to to our parent name in alkanes, we call that a substituent. So when I'm talking about substituent, I'm talking about any compound that is attached to our parent's name is called a substituent. So now we have methyl attaching to our parent's name. So this is methyl because it only has one. So I'll call this methyl pentane. So just naming this methylpentane is not accurate, is not that correct. Why? Because methyl can be here, methyl can be here, methyl can also be here. So calling it methylpentane is not accurate. So the best possible name to call this compound is by saying or naming this nomenclature of this compound what? 2-methyl-pentane. So when you call this 2-methyl-pentane, you are now accurate. So I know some people will now be confused about what is methyl talking about. So before I start naming this compound, let's describe.
Please don't forget to subscribe, like, and hit the notification bell for more videos like this on Sagacious Learners.
Hydrogen. What of if you have this? So first thing I'm going to do is to expand this structure. So I'll first write my hydrogen because this carbon is attached to my hydrogen. So I have another 3 space. So this 3 space is pointing towards this dimension. So since this 3 space points towards this direction, so what should I write? Should I start from this CS3 or should I start from this CS2? So The answer is you have to start from the CH2, because if you attach this CH2, if you attach this CH2, you end up having this, and you have under another space to attach these ones here. But if you start from CH3, you end up filling the carbon, so there will be no more space for binding. So therefore writing CH3 is definitely wrong. So you should always start from CH2. Start from what? CH2 if you want to expand a diagram. So I have CH2 1 2 3. Then before my CH3 what, which is what? CH3, because I have 1 2 3 and what 4. So 1 2 3 and 4. So here the same thing, CH2 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 then CH3. So all this thing has a bond. So here the same thing, CH2 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 then CH3. So this is how you can expand this. Now we have expanded this. How can we name this carbon? How can we name this compound? So naming this compound, we have to look for our longest continuous chain. So to find or to identify our longest continuous chains, let's start counting. So are we going to like start from this? Are we going to count like this, or are we going to count like this, or are we going to count like this? Definitely counting like this and counting like this will actually give you the same thing. So the question is, are you going to start from like this, or are you going to start from like this? So let's check. So the only method we have to start from, we have to look for our parent chain. In order to identify our parent chain is 1 2 3 4 5 6 7 8 9. So I have 9 if I should count from this dimension, but what of if I should count like this? 1 1 2 3 4 5 6 7 8 9. Wow, I still have 9. So both of them will give me 9. So whether I start from this direction, or from this direction, or from this direction, all of them will definitely give me 9. So our parents chain is nonane. So our parent chain is what? Nonane. So since our parent chain is nonane, what will be the name of this compound? So the name of this compound will be, let's check well. So what will be my substituents? So my substituents, I can decide to choose this direction as my substituent. I can decide to choose this direction as my substituent. I can also decide to choose this direction as my substituent. So anyone you feel like choosing as a substituent, you can go ahead and choose. So our substituent today is 4. So which carbon atom in which N is equals to 4 as a substituent is an alkyl group is what? Butyl. So the name of that carbon is what? The name of our substituent here is butyl. Since the name of our substituent here is butyl, because it is 4, that is why we call it butyl. If it starts from here, it's also 4. That's why we call it butyl. If it also starts from here, it's also 4. So that's why we call it what? Butyl. So what should be the name of this compound? So the name of this compound, choosing anywhere as your parent's name, you end up getting this carbon as your number 5. So since you end up getting this carbon as your number 5, it will now be the central carbon or the chiral carbon. So therefore, it will now have 5. So the name of this compound will now be 5-butyl nonane. So the name of this compound is 5-butyl nonane. So let's practice more questions under this topic. Compound, how are we going to name it? So definitely we have total of 9 carbon as my parent chain, which is 1 2 3 4 5 6 7 8 9. So this substituent is attached at the 4, so this will be called 4-methyl nonane. So this is 4-methyl nonane. 4-methyl nonane. So what of compound? So naming this compound, what is our longest continuous chain? Our longest continuous chain will be 1, 2, 3, 4, 5. So our longest continuous chain will be in this direction. So I now have how many substituents? That is the question. How many substituents now do you have? Okay, what of if you decide to start from maybe this dimension? You see, you still end up getting up 5. 1, 2, 3, 4, 5. You end up getting 5 soon. So any direction you start from, your longest continuous chain will end up being 5. So since our longest continuous chain is 5, which is pentane, now what is our substituents? Our substituents will definitely become 2-methyl, because there is methyl, 3-ethyl. So this is an ethyl group, which I can write it as CH5. So this is 2-methyl 3-ethyl pentane. So this is 2-methyl, but methyl and ethyl, which one comes first? So the one that definitely comes first is ethyl. So naming this compound, you write 3-ethyl 2-methyl pentane. So that is the name of this compound, 3-ethyl 2-methyl pentane. So our longest chain will definitely be, if I start from this direction, which is this, I will end up getting 4, which is wrong. So if I start from this direction, I will end up getting 5, which is a bit accurate. If I also start from this direction, I will end up getting 5, which is also a bit correct. If I also start from this direction, I will end up getting, let's check, 1, 2, 3, 4, 5. So I'll end up getting what? 5. So the best direction to start from what is any direction that will end up giving you 5. So our longest continuous chain, which is the parent chain, the unbranched chain, is what? Pentane. So like this is what we call pentane. So it means we have pentane. So how many substituents do we have? We have 3 substituents, which is 1, 2, and 3. I'm trying 3 substituents, where this is what's called what? My ethyl group, which I'm going to name alphabetically. Ethyl comes first. So in naming this compound, I'll start from ethyl. And where is this ethyl located? This ethyl is found here. Nice. In this compound, will I start from the left or will I start from the right in naming this compound? So that is a question. So those that said left, you guys are wrong. Those that said right, you guys are also wrong. Now they will tell me the people that are correct is those that said what? Left. So people that said left, they are correct. So because if I should end up starting from here, let's check. If I end up starting from here, I have 1, 2, 3, 4 and 5. But if I should end up starting from the opposite side, okay, let me explain something. So therefore I'll have my substance, which is ethyl. I have my substance as 3, and I have my substance as 3, and also have another substance as what? 4. But if I should end up starting from the left, I have 1, 2, 3, 4, 5, 6. So therefore 5, not 6. There's no 6 here. 1, 2, 3, 4, 5. There's no 6 here, so cancel this out. So if I should end up doing this, I'll end up getting 2, 3, 3. So remember, in naming compound, we're going to end up giving the compound the lowest possible name in order, like the lowest possible number. So you should have that in mind. When you're naming organic chemistry, you should end up giving that compound the lowest possible number. So the lowest possible number here is what? 2. So people that start from right are wrong. People that are correct are students that start from left. Students that start from right are more accurate and more correct. So to name this compound, you're going to start from left. Why? In order to give the compound the lowest possible number. So to name this compound, I'm going to call it what? 3-ethyl. So 3-ethyl, what again? 3-ethyl 2,3 dimethyl. So why is it di? Di because of I have 2 methyl substituents. That is why we call it di. Then what is the parent chain there? Pentane. So the name of this compound is 3-ethyl 2,3-dimethyl pentane. What if I have this? What am I going to do? Where should I start? So to name this compound, obviously, which we all are seeing, is whether any dimension or any direction you start from, you end up getting the same thing. Trust me. But I want you to understand something is, if you start from this direction, you end up getting that as the parent chain, which is also correct. Someone that starts from like this will also get the same, which is also correct. Someone that also starts like this, definitely all of you are correct. So why I said all of you are correct, because you have 1, 2. So you have 2 carbon atom before this long chain here. You also have 2 carbon atom like this before this long chain here. So you also have 2 carbon atom before this long chain here. So any dimension you decide to start from here is correct. But the problem is, why, like, the problem here is you should just start from any direction. Yeah. So starting from any direction or dimension is because you end up getting the same thing no matter the direction you start from. So if you expand this structure, definitely we end up getting 7 + 1, which is 8, which is octane. So my longest continuous chain here is 7 + 1, which is 8, plus 9, which is nonane, plus 10, which is decane. So this long carbon here is what's called what? Decane. Let's check. 1 + 2. 1 + 1, which will give me 2. 2 + 7, which will give me 9. 9 + 1, which will end up giving me 10. So any dimension you now start is absolutely correct. So if you expand these structures, which you are going to do by yourself, now I have 1 and I have 2. That means I have 2 substituents. So to name this compound, I will call this 2,2 hyphen dimethyl. 10 is what? Decane. So like have this structures in your mind. So the question is, what if I have this? So in order to name this compound, we all can see my longest chain is in this dimension, which is 1, 2, 3, 4, 5. So which is 5. So to name this compound, we call this pentane. So how many substituents do I have? Okay, let me take another dimension. If I should start from this dimension, I end up having 1, 2, 3, 4, 5. The same thing. So any dimension starts from, you end up getting the same thing. So therefore, what I need is to find how many substituents attached to this group. So how many substituents attached to this group? So therefore, I can see 5. 1, 2, 3, 4, 5. So these are my 5 substituents attached to this group. So since I have 5 substituents attached to this group, so in this compound, will I start from the left or will I start from the right in naming this compound? So the truth is, students that start from right are wrong, but those that start from left are correct. Why? Let's check. 1, 2, 3, 4, 5 for the left hand side, which is I have 2, 2 I have 3, 3, and I have 4. But if I should start from the right, I'll end up having 1, 2, 3, 4, and 5. So I'll end up having 2, 3, 3, and I'll end up having 4, 4. So you see, this one is like more bigger when compared to the yellow ones. So in naming this compound, you have to start from the left. So starting from the left, we now have, which is we end up having 4, 4, 3, 3, 2 pentamethyl pentane. So this is 4, 4, 3, 2 pentamethyl pentane. You know, when we have 1 in chemistry, we call it mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. So it is 5. The substance we have is 5, so we call it penta. So this is 4, 4, 3, 3, 2, means since there are 5, 1, 2, 3, 4, 5 attached to a compound. So we now, because of their 5 and they are all methyl, so we now call it pentamethyl. So you see there is no hyphen in this 3 because of it is word to word. But once it is number to alphabet, hyphen, number to number, semicolon. So just note that basic principle. So what of if we have CH3, CH2, CH2, CH attached? We have CH, we have CH3, we have CH3, and we now have here CH2, we now have here CH, we now have here CH3, we now have here CH2 and CH3. So what of if we have this? How are we going to name this compound? Remember earlier in this video, remember in organic chemistry, isopropyl is this. So whenever you hear about isopropyl, definitely you're talking about this structure here. So isopropyl is that Y structure. So from this compound I can see isopropyl. So this isopropyl, I can write this as CH3, CH3, then this C hydrogen, then attached to my carbon. So that is what you can see here. So it is clear there. So that compound there is called isopropyl. Isopropyl. So now I have this now. So how am I going to name this compound? In naming this compound, will I start from the left? So first, what is my longest chain? That is something you have to put in mind. Is so those that just did this is wrong, because this is not my longest chain. My longest chain is this. Let's check. If I start from a 1, 2, 3, 4, 5, 6, 7, I end up getting 7. But if I start from I end up getting 1, 2, 3, 4, 5, 6, 7, 8. So my longest continuous chain is 8, which is what? Octane. So therefore I will definitely have. So if I should I start from the left or should I start from the right in naming this compound? Definitely I will start from the left, because if I should start from I will start from the right, because if I should start from the left, I will end up having 1, 2, 3, 4. I will end up having my isopropyl at 4 and having my methyl group 5 6 at 6, so which is very high. But if I should start from my right, I will end up having my methyl at 3 and having my propyl at 5. So 3 and 5 and 4 and 6, this one is more lower, so it's 3 and 5. 3 and 5 is more lower than 4 and 6. So I'll definitely, to name this compound, I will start from the right. Starting from the right, I now have iso and methyl. Which one comes first in alphabetical order? So let's check. A B C D E F G H I J K M. So in alphabetical order, I comes before M. So to name this compound, I will call this 5 because it is attached at 5. So I will call this 5 isopropyl. 5 isopropyl 3 methyl octane. Let's confirm whether what we name is correct. 1 2 3 4 and 5 6. But if I start from a 3 and 5, so what we did is correct. 5 isopropyl 3 methyl octane. So this is the best name for this compound. 5 isopropyl 3 methyl octane. Now, what of if we have this CH3 CH2 C CH2 CH3 CH2 CH3 CH2 CH CH3 CH3. So the first thing you have to do here is to identify your longest continuous chain. So to identify your longest continuous chain, is it in this direction? Let's check our longest continuous chain. So for me, my longest continuous, okay, 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5 6. So my longest continuous chain is 6, which is hexane. So in naming this compound, will I start from the left or will I start from the right? So the answer is you have to start from the right, because if you start from the left, you end up having substituents such as, if you start from the right, you end up having 3, 3 and 3 4 5 and 5. But if you start from the left, you will end up having 2 1 2 2 and 4 4. So 2 4 4 and 3 3 5, which one is more bigger? Definitely 3 5 5 is more bigger than 2 4 4. So I'm going to start from the left to name this compound. So starting from the left, and I have 1 2 3 4 5 6. So my longest continuous chain, which is the hexane. So therefore this compound gonna be 4 4 di is because there are 2 diethyl 2 methyl what hexane 4 4 diethyl 2 methyl hexane. So that is the name of this compound. Now let's go over to the more complex one. So in this one, what I'm going to be doing is, as I write the name, you will be the one to tell me you will be the one to draw the structure for me. As I write the name, you're going to be the one to draw the structure for me. So let me introduce you to TETs. So when we talk about TETs, what comes into your mind? So this is the structure of TETs. So this isopropyl is this, Why the structure of text is this. Okay, now, so whenever I talk about the structure of text, so what should come into your mind is this structure here, which is the structure of text. So the structure of text, which is CH3 attached, which they are three attached to my carbon. So just take a look at that structure very well. So when you talk about the structure of text, that is the structure of text. So if you expand this structure, you end up getting CH3, CH3, and CH3. So this structure now, as you can see it here in the skeletal structure, look at the structure there. So that structure there is equivalent to this structure here. So this is text butyl. So whenever you just hear about text butyl, so that is what I'm talking about, text butyl. So this is what I'm talking about when I said text butyl. So where this will now attach to our longest continuous chain. So let's start drawing structures on text butyl. So but now we're not going to be drawing structure. What you are going to be doing for me is, as I ask you question, or as I give you a name of organic compound in alkanes, what you're going to do is you're going to use that name to draw for me the structure. So I'm going to like write for you example of what I mean. So if I just say 3,3 dimethyl butane, so I just write the name. So what I'm expecting you is to use this name and draw the structure. So to draw this, first my longest continuous chain, which is butane. So I'll first and what I write 4, which is what 4 carbon atom, which are what butane. So I have 3 since I have 3 I'll come here and draw my methyl group, draw my methyl structure, then I'll now complete 3 dimethyl. So my substance is gone, my butane is gone. So what I have to do now is just to complete this carbon. So in order to complete this carbon, so this is the process I have to go to complete this carbon. So if this was the skeletal structure, so to draw this in a skeletal structure, and skeletal structure is more faster. So to draw this in a skeletal structure, you have to just do something like 1, 2, 3, 4. So I have 1, 2. So this is the skeletal structure. If they, in case we ask you to draw the structure, but I will do a special video for a skeletal structure, drawing this in a skeletal structure manner. So your first question is, remember, isopropyl is this, why text butyl is this. Don't forget, don't forget. Or if you want to draw it very well, you can decide to do something like this. So this is your isopropyl, why the other one, which is so this one does not have hydrogen, this one is just stress, why this one, the isopropyl, have hydrogen. So don't forget this. So your first question now is, draw the structure of 4 text butyl hyphen 3, 3, 5 trimethylheptane, so draw using this name, draw the structure of 4 text butyl 3,3,5 trimethylheptane. So pause this video, go ahead and try drawing it. So in order for you to draw this effectively, what you have to do is, first, what is your longest chain? Your longest chain is heptane, which is 7. So let's draw 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I have my 7, so I have my 4 sets butyl as my substance, which is attached as the 4. So 1, 2, 3, 4. So note that in organic compound, if you're given a structure and you're asked to you have given a name and asked to draw the structure, so you can start from the left, you can start from the right. Everything is on your own wish. So I'm deciding, so I can start from anywhere, I can draw from anywhere. So look at this. So for me to draw this, so 4, I have to locate 4. 1, 2, 3, 4. So I decide to use here as my 4. Since I decide to use it, I have to like correspond this from the right to the left. So from this structure, from this name, I'm trying to draw this structure from the left to the right. Another person might decide to use from left to right. So we are still talking about the same thing. 1, 2, 3, 4. So this is my 4 sets. My 4 sets is this structure: CH3, CH3, CH3. So this is 4 sets butyl. So this one is out of my way. So next I have is 3, 3, 5. So since I have 3, so I'll come here and draw my 3, CH3, CH3. I have 3, 3. So 3, 3 is out, and I have 5. So this is 1, 2, 3, 4 and 5. So my next one is what? 5, which is CH3, and here will become what? Definitely become hydrogen. So 4 thirds butyl, which is this diagram here. 3, 3, 5. So this is 3, 3, and this is my what? My 5. So 4 thirds butyl, 3, 3, 5 trimethyl is gone. So what I have is now my heptane. So I have to just complete this with hydrogen atoms. So definitely this is the structural formula of 4 thirds butyl, 3, 3, 5 trimethyl heptane. Now what of if you are asked to draw 2,4-dimethyl pentane? You are asked to draw 2,4-dimethylpentane. So why are you going to draw this structure? So drawing this structure is, so I think this is one of the simplest structure we have drawn here. So drawing this structure is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and I have my 2, 4. So I will go here and add my methyl. 2, 3, 4. I'll add here as my words 4. So therefore this is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 2,4-dimethylpentane. Now what if you are asked to draw 4,4-diethyl 3-methyl octane? 4,4-dimethyl 3-methyl octane. So what if you ask to draw this structure? So to draw this structure, first you draw your longest continuous chain. So I'll decide to draw this in a skeletal manner structure. So drawing this in a skeletal manner structure, so what I have to do is to draw it first. 2, 4, 5, 6, 7, 8. Or 10 is 8. Let's check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Octane is 8. So in every juncture there is always a carbon atom. So in every juncture, what I mean is here there is a carbon atom, 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 and there is a carbon atom. So if you calculate, you end up having 1, 2, 3, 4, 5, 6, 7, 8. So there is all structures, there is all carbon atom in each juncture. So since we have 4 carbon atom in each juncture, so since I have 4 so where is my 4? You can see here is my 4. So I'll come here and write 4 dimethyl. So methyl just has a structure which is a straight line. So anytime you see a straight line, we're talking about methyl, and methyl is CH3. So anytime you see methyl which is CH3, we're talking about a straight line. So I'll just go ahead and draw my straight line, so which is at 4, and I'll draw another one which is at 4 because they said 4 dimethyl. So therefore 3 methyl. So I'll draw another one. So and I have 4 dimethyl 3 methyl octane. So what if I have 3 isopropyl 2367 tetramethylnonane? But before I do that one, let's just draw a structure. You see, going back to this structure, you see 4 dimethyl 3 methyl octane. This name is definitely wrong. So there is inaccuracy in naming this compound, so the name is wrong. So anytime you see this in theory, just tell them this is wrong. There is nothing like this. The actual or proper name of this compound should be 3,4,4 trimethyl octane. 3,4,4 trimethyl octane. There's nothing like this in organic chemistry. 4,4 dimethyl 3methyl octane is wrong. So what if we have 4,4 diethyl 3methyl octane? So what if we have 4,4 diethyl 3methyl octane? What if we have this? So what will be the first thing you have to draw? So the first thing you have to draw is the 8. So first I'll draw this using skeletal structure. So I have 1 2 3 4 5 6 7 8. So 1 2 3 4 5 6 7 8. So let me name it 1 2 3 4 5 6 7 8. So this is octane. It is octane. So now I have 4 diethyl. So I'll come here and draw this structure. 4 diethyl. This is definitely 4 diethyl. So methyl is 1, therefore ethyl gonna be what? 2 lines. Let me draw this in a way you understand. You know, we all know that ethyl is this. So if you want to definitely draw this structure, this is the structure of ethyl. So this is now attached to any stupid something, any organic compound we know. So ethyl is this, why methyl is this. So what of propyl? So just you, when you are drawing all this skeletal structure, your main points or your end point should, in alkyl group, you should end up having 3 junction. As you can see, methyl, I have only 1, meaning that the carbon atom is equivalent to 1. If it's ethyl, the carbon atom will be equivalent to 2. So I have 2 junction. So if it's propyl, the carbon atom will be equivalent to 3. So I'll end up having something like this, 1 2 3. So I'll end up having 3 equivalents. So I have 4 diethyl, meaning that they are 2. So this is the structure: 4 diethyl 3 methyl. So methyl is 1, 4 diethyl 3 methyl octane. So this is the skeletal structure. So but when you are asked to draw the normal structure, you know, we are going to end up drawing octane, and this structure is very long: 1 2 3 4 5 6 7 8. I'll put my 3 hydrogen, I will put my 3 hydrogen, and I will put my 4. 4 1 2 1 2 3 4. So my 4 is where? Ethyl 2CCH5, ethyl 2H5, and my methyl, which is this. So I'll just complete all these things with hydrogen atom. So this is the structure of this compound here. Now, what of if you are asked to draw 3 isopropyl? 3 isopropyl, 2, 3, 6, 7 tetramethionine, So this structure is 3 isopropyl, 2, 3, 6, 7 tetramethionine. So how are you going to draw this structure? Definitely, drawing this structure is first draw your skeletal structure, which is the nonane. So I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, I have 7, I have 8, I have 9. So this is my longest continuous chain in the skeletal structure format. So I have my isopropyl. So I have 1, I have 2, I have 3, I have 4, I have 5, I have 6, 7, 8, 9. So this is 3 isopropyl. So my isopropyl is in 3. So 3, 3 is the structure of isopropyl. So now I have 2, 3, 6, 7. Remember that isopropyl is this. So isopropyl, talking about this. So or this. So this structure of isopropyl. So then I say 3 isopropyl. So it's in my 3. So then I said 2. I have my 2. This is a methyl group. First is in 2. And then I said 3 again. Another isopropyl in my 3 again. Then I said 6. So I have another methyl in my 6 carbon parent chain atom. Now then I said 7. So I have 7. So this structure is what we call 3 isopropyl, 2, 3, 6, 7 tetramethionine. Now, if you want to draw this in a simpler format, in a format that will not actually confuse us, so just in any format you draw is acceptable, but the skeletal structural formula will make you more faster, and it makes you looks more faster. Yeah. So to draw this in our normal diagram, we have 1 2 3 4 5 6 7 8 9. So 1 2 3 4 5 6 7 8 9. So I have 9. Then I said 3 isopropyl. So it is in 3. I'll draw my C. I'll draw my isopropyl, which is this diagram here. Then this carbon is not definitely complete, so I'll end up adding hydrogen. So this is the structure of my isopropyl. Then I said 2. So I have a methyl group in 2. And then I said 6. So I have a methyl group 1 2 3 4 5. So I have a methyl group in 6. So 7. I also have a methyl group in 7. So this gonna definitely be my structure of 3 isopropyl, so just fill up the hydrogen atom. So this is gonna be the structure of 3 isopropyl, 2 3 6 7 tetramethionine. Now the question is, what if we have 2, 2, 3, 4 tetramethylpentane? So tetra, So this is not the spelling of tetra. Tetramethyl pentane. So 2,2,3,4 tetramethyl pentane. Definitely drawing this structure is simple. So this is 1, 2, 3, 4, 5. So 2, I have it at my 2, I have it at my 2, I have it at my 3. They say tetramethyl pentane. So this is the structure of 2, 3, 4, 2, 2, 3, 4 tetramethyl pentane. But if I want to go ahead and draw it in our normal manner, so I'll draw this 1, 2, 3, 4, 5. So I have 5. So they say 2, 1, 2, 3. They say 2, 1, 2, 3. They say 3, 1, 2, 3. So they said 4. 1, 2, 3, 4. So I'll be the one to definitely complete all this. So you see how stressful this one is. So therefore, drawing skeletally is recommended, and for me, I usually say is the best. Yeah, is actually the best for me. So if you have 3 ethyl 2 comma 3 trimethylpentane. So if you have this 3 ethyl 2, 2, 3 trimethylpentane, so to draw this 1, 2, 3, 4, 5. So I have 5. I have my ethyl which is 2H5, and they say this is in 3, not 2. So we can definitely start from here to definitely H5. So then I say 2, 2. So I have 2, which is CH3. I have another 2 because they say 2, 2, and I have 3, which is CH3. So this is what we call 3-ethyl-2,2-3-trimethylpentane. But what if you decide to draw in a skeletal structural format? So to draw in a skeletal structural format, you have to just do this way: 1, 2, 3, 1, 2, 3, 4, 5. So this is a pentane. So they say 3. So I'll just write 1, 2, 3, 4, 5. Writing all these jiggy number, they are not that useful. It's not useful. I'm just doing this for you to like understand what I'm doing. But definitely, if you are doing yours, no number is expected to be there. So there is no number expected to be here. So you're just actually expected to just write it directly. No number is expected to be there. I'm doing it so you see where I'm heading to. So this is 3. So your structure is expected to look like this: 3-ethyl 1, 2, 3, 3-ethyl, because there is an ethyl group. Let me draw it very well. 3-ethyl, and I said 2, 2. So 2 here, 2 here, and 3, 3. So this is 3-ethyl 2, 2, 3 trimethylpentane. Observe something, that I draw my 2, 2 trimethyl in this manner. As you can see here, I draw it to be like this. Why? Some people can also decide to draw like this, so it's just choice. So some people can also decide to draw like this. Both of you as to correct. Now, what if we have 3, 3 diethyl 2, 2, 4, 4 tetramethylpentane. So this is tetra. This is tetramethylpentane. So what if we have 3,3-diethyl 2,2,4,4 tetramethylpentane? So to draw this, just go straight to the point and draw carbon, 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 which is 5. Pentane is 5. So I have 3 in my die. So I'll go to my 3 straight and I'll draw my 3,3-diethyl, which is 2C. This is 2CH5. Okay, let me draw it very well. So this is 2CH5. But for you to be in a silver side, for you to draw it well for you to be in a silver side, I always advise my students, anytime they say it, they should expand it fully. What I mean is drawing it this way and not this way. So if you ask to draw it, say if you're using this method, I will not really encourage you to draw this way. So draw it this way as a substituent. If you're indicating it as a substituent, always draw it this way. But drawing it this way actually you not really affect your mark or your score. But I like actually advise students to draw it in that manner. So drawing it this way, now we now have CH2 CH3. So this is my ethyl 3,3-diethyl. So I have 2,2,4,4. So I have 2 CH3, I have 2 CH3, I have 4 4 4. So I have another CH3 and I have another CH3. So and I have CH3 and I have CH3. So this is the structure of 3,3-diethyl. As you can see, 3,3-diethyl 2,2,4,4 tetramethylpentane. But what if you decide to draw it in a skeletal structural format? So if you want to draw it in a skeletal format, which is the easiest and faster to draw, so just draw pentane, which is 1 2 3 4 5. So this is my pentane structure. So this is 3 3. So it's attached to the 3 ethyl. This attaching to ethyl, I have something like this as my substituent. Now then I said 2 2. So I have 2 and I have 2. So and I also have 4 4 4 and 4. So this is a show of 3,3-diethyl 2,2,4,4 tetramethylpentane. Another person can also decide to draw the skeletal structural format in this manner, which is 1 2 3 4 5. So that person might decide to draw 3 ethyl, let's say 3,3-diethyl 2,2-methyl 4 4. Both of you are still correct. So I think this is my last video in nomenclature of alkane. So the next topic we're going to be doing is cycloalkane. That means naming cyclic alkanes. So our next topic will be on cyclic alkanes. So in this part of this lecture, we are going to be talking about naming of cycloalkanes. Now let's just dive deep to our main focus. So let's start by what are cycloalkanes. Just as cycloalkanes, what are cycloalkanes? So condensed structures become awkward when we work with large molecules that contains rings. Thus, line structures are used almost exclusively in drawing cycloalkanes, with polygons used for the cyclic parts of the molecules. A triangle represents cyclopropane, a square represents cyclobutane. A pentagon represents cyclopentane, and so on. So let's start drawing on the structure we just mentioned now. So cycloalkanes are just alkanes in cyclic manner. When you're talking about cycloalkanes, we're definitely talking about alkanes in cyclic manners. So our first alkane, the lowest alkane group, which is what we call this structure here, which definitely we call this cyclopropane. So once you hear about cyclopropane, we are talking about this diagram here. If you hear about cyclobutane, I didn't get this diagram very well. So this is what we call cyclobutane. Now once you hear about this structure, so from what you have been observing now, what will be the name of this compound? So the name of this compound is what? Cyclopentane. Why is it cyclopentane?
Hey brilliant minds, this is sagacious learners where science comes alive. If you're preparing for JAMB, clinical or GCA, or you're a 100 or medical student studying anatomy, physiology, biochemistry, physics, chemistry or biology, then I have got something special for you. I offer private and group online lessons designed to help you understand deeply and succeed easily. Just send me a WhatsApp message on 08163207065. Don't just study hard, study smart with sagacious learners. Let's grow your mind together.
It is cyclopentane because we have 5. 1, 2, 3, 4, 5. There is 5 carbon atom here, so definitely we are going to call it cyclopentane. Why in the other two we have 1, 2, 3? So since we have 3 and 3 is propane, so since it's nomenclature of cycloalkanes, I'm not going to attach the name cyclo to it, so therefore we call it cyclopropane. Why in this one we have 1, 2, 3, 4? So we definitely have butane, which is equivalent to 4 when n is equal to 4, when number of carbon atom is 4. So we definitely call it cyclobutane. We call this the cyclopentane because number of carbon atom is equivalent to 5. So since the number of carbon atom is equivalent to 5, we call it pentane. So therefore pentane means cyclopentane. Now let me draw this structure in a way I think you will better understand. So there should be a carbon atom here. So this structure on yellow is the same thing as this structure here. So both of them are still this thing. So I just like indicate the number of carbon atom. So therefore here we have a hydrogen, 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 hydrogen. Why? Carbon is always 4. Carbon is never 3. Carbon is always 4. So if I should leave it in this way, meaning this carbon is incomplete, so we're going to attack this hydrogen atom in order to complete the hydrogen atom. So therefore we have hydrogen, 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 and hydrogen. To complete it 4. So anyway you see this diagram, just know that there is always two atoms of hydrogen attached to this, unless this hydrogen is being replaced by a substituent, an alkyl group. So whenever you see a cycloalkane, there is always 2 hydrogen, unless it is replaced by a substituent, or there is presence of double bond, as we can see in benzene. In benzene ring where we have something like this, or you have something like this. So this is not a good schematic structure of benzene ring. So a benzene ring, let me show you example of a benzene ring. So a benzene ring is a bit, so something like this. So there's always a double bonds, but not in all parts of the carbon atom. So but there's always a double bond. So just have that in mind. So let's go further to draw some structures we know about. What if we have this? So this is definitely called what? Cyclohexane. Why is this cyclohexane? 1 2 3 4 5 6. So there is 6, so we call it cyclohexane. Now what if we have okay, go ahead and draw the structure of cyclopentane. So this one is for you. Draw for me cycloheptane. So go ahead and draw cycloheptane. So to draw cycloheptane, what will be the first thing you have to draw? So we have to draw this, and this. There is 4 here. 1 2 3 4 5 6 7. So this is what we call cycloheptane. Or let me draw it in a way let me make it more presentable. So this is cycloheptane. Now let's go change some substituents. So now we have this. How are we going to name this compound? This compound here. So to name this compound, we definitely call this compound methyl cyclohexane. Why is it called methyl? Because this substituent here is a methyl group, and this parent name here is called what? Cyclohexane, because the carbon atom here is 6. So to call this, we call it methyl methyl cyclohexane. So this is definitely called methyl cyclohexane. Now what if we have something like this? Where here is my ethyl group, and here is my methyl group. So what is the name of this compound? So to name this compound, we have to call this what? First, you have to identify the longest continuous chain, which means the longest continuous chain is this cycle. So this cycle, we call this cycle what? Cyclohexane, because there is 6 carbon atom. There is 6 carbon atom. 1 2 3 4 5 6. So we call this cyclohexane. Since this is called cyclohexane, so what are the substituents? So the substituents here are definitely ethyl and methyl. So I don't think this is a new thing in my YouTube channel. So just if you don't understand this part, just go back to the previous video in this playlist. You understand this part very well. It's not something you have to worry about. So this is ethyl, this is methyl. So how are you going to name this compound? Naming this compound, ethyl comes before methyl. So we're going to start from alphabetical order. So ethyl always comes before methyl. So to name this compound, we're going to call this what? Ethyl methyl cyclohexane. But we're not going to call it ethyl methyl cyclohexane, because if you just say ethyl methyl cyclohexane, means that anyway I write this particular compound is correct. So you're going to identify the particular number in the ethyl methyl cyclohexane. So to name this compound, are you going to start from the left or are you going to start from the right? So definitely you will start from here. 1 2 3. Why didn't you start from this way? Instead, we started from this way. Why? The reason behind it is you have to give the compound the lowest possible name, and some people think of starting this way, which is wrong, because if you start this way you end up having 1 2 3 4 5. So you end up having 1 and 5 instead of 1 and 3. So 1 and 5 and 1 and 3, which one is smaller in numerical order? So 1 and 3 is smaller than 1 and 5. So we go by what? 1 and 3. Our main major product is to give this substance the lowest possible name. So we go by 1 and 3, not 1 and 5. So take note of that. So you have to name this in order to give it the lowest possible number. So since we have this, so to name this compound, we now call it what? 1 ethyl 3 methyl cyclohexane. So this is 1 ethyl 3 methyl cyclohexane. Okay.
Hey brilliant minds, this is sagacious learners where science comes alive. If you're preparing for JAMB, clinical or GCA, or you're a undergrad or medical student studying anatomy, physiology, biochemistry, physics, chemistry or biology, then I have got something special for you. I offer private and group online lessons designed to help you understand deeply and success easily. Just send me a WhatsApp message on 08163207065. Don't just study hard, study smart with sagacious learners. Let's grow your mind together.
So what if we have this? Okay, what if we have this? So the name of this compound is called, okay, think of the name of this compound. if you actually get this name, I'm telling you, you are good. So the name of this compound is what we call cyclobutyl cyclopentane. Cyclobutyl cyclopentane. Why this cyclobutyl and why this cyclopentane? So this cyclobutyl, this is the substituent. The substituent is cyclo, and we call it butyl. You know, a substituent, especially a substituent which is the alkyl group, usually lacks 1 hydrogen than the corresponding alkane group. So since this substituent usually lacks 1 hydrogen corresponding to the alkane group, so instead of calling it AN, instead of ending the name with ANE, we have to end it with what? YL. So cyclobutane, we now call it what? Cyclobutyl. So anywhere you see ANE and that compound is lacking 1 hydrogen atom than the original alkane group, we call this an alkane group, and it's going to end with YL. So this is cyclobutyl because of this compound, and this is now cyclopentane. As you can see here, we have 5. 1 2 3 4 5. So this is 1 2 3 4 5. So we have 5. So we call this cyclobutyl cyclopentane. So that is the name of this compound. And you should note also that cycloalkanes has general molecular formula of CnH2n, than the normal corresponding alkane. You know that alkane has general molecular formula of CnH2n plus 2. So alkanes usually have general molecular formula of CnH2n plus 2, but cycloalkanes usually have general molecular formula of CnH2n. Why? Let's go back to our previous structures. So in our previous structures, where we have this, where we have this cyclohexane. So in this cyclohexane, you should observe something. There is a carbon atom here, but then to this hydrogen. So this is lacking by 2 hydrogen. Formula CnH2n plus 2. So this 2 hydrogen is no more there because of there exists a bond between a carbon atom towards another carbon atom, and this carbon atom is also bonded towards another carbon atom. So therefore this formula I now have general molecular formula of CnH2n plus 2. Now this, so we now have this connected to this connected to this, connected to this. Now how are we going to name this compound? So first, to name this compound, you have to find your longest continuous chain. So what is your longest continuous chain? So let's check. 1 2 3 4 5 6, and we have here definitely 1 2 3 4 5. Are we actually making sense? Yep, we are actually making sense. So we have 5 and we have 6. So on our normal basic chemistry, from here should be our parents compound, but no, our parent compound is here, which is 1 2 3 4 5. This is our parent compound. Why? Because of this carbon in these sets has more substituents than this carbon in these sets. So due to this reason, this now bears the parent's name. Now this carbon here now bears the parent's name instead of this, because the carbon by my right hand side has more substituents than that of the left hand side. So due to this reason, this now becomes the parent's name. So what is the parent's name? So the parent's name is pentane, because it is 5 indicating pentane. Since it's 5, it's not indicating pentane, so this definitely will not become a substituent. So since this is not a substituent, we have to call this cyclohexyl. But not just cyclohexyl. If you just say cyclohexyl, meaning that I can draw this structure putting this cyclohexyl in any part I want in this parent's name. So to be more specific, to be more accurate in your naming, you're going to call this tricyclohexyl because it is attached to the tri-carbon. So you're going to call it tricyclohexyl. So let's start naming. Tricyclohexyl 2,2,4-trimethylpentane. Why is this 2,2,4-trimethylpentane? Because there is a methyl group here and there is a methyl group here. So definitely we're going to call this 2,2, not any other thing you're thinking of. It is 2,2 because it is attached to this carbon atom here. So you're going to call this 2,2. So this will now become 2,2, but we do not have just have 2,2. We also have 4. So in this 3 we also have 4, and we also have a substituent which is a methyl also attached at the carbon atom of 4. So we also have a substituent which is we have 2,2, and we also have what?
Hey brilliant minds, this is sagacious learners where science comes alive. If you're preparing for JAMB, clinical or GCA, or you're a 100 or medical student studying anatomy, physiology, biochemistry, physics, chemistry or biology, then I have got something special for you. I offer private and group online lessons designed to help you understand deeply and succeed easily. Just send me a WhatsApp message on 08163207065. Don't just study hard, study smart with sagacious learners. Let's grow your mind together.
4. So to name this compound, let's call it tricyclohexyl, because this hexyl, instead of hexene, they put YL, is now acting as a substituent. So this is tricyclohexyl 2,2,4 trimethyl, what's our parent's name, which is what, 5, and it's called pentane. So you have to be wise. 5, 6, 7, 8, 9. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9. So we now have 9, which is nonane. We now have 6. That should be 6. Let's check 1, 2, 3, 4, 5, 6. So we have 6 and we have 9. So from our mind, first, before giving you hints on how to name this compound, try doing it yourself and see what you can do. And let's just go straight to the point now. So at this juncture, what are you expected to do? So what you are expected to do is to identify your parents' compound. So you know, in our previous example, that our parents' name, our parents' compound was based, when you're naming cycloalkanes, your parents' compound usually depends on the one that has more substituents rather than the one that has the longest continuous chain or unbranched chain. So when you're talking about the parent's name or the parent's compound, the parent's name is the one that has more substituents than the other. So anyone that has more substituents than the other will be the parent's name. So as you can see in this compound, if you take this compound as my parent's name, is wrong. Why? Because it only has one substituent. So since it has only one substituent, is wrong. But if I should take this compound as my parent's name, it will now have 3 substituents: isopropylmethyl and nonane. So this nonane, so I'll just replace that ANE with YL. So whenever an alkane group is acting as a substituent, you just replace that ANE with YL. So instead of calling this nonane, so I'll just call this what? Nonyl. So this is nonyl, NONYL. So this is nonyl. Now I have this. What am I going to do now? So to name this compound, our parent's name becomes what? Cyclohexane. Since our parent's name is cyclohexane, which dimension should I start in writing this compound name? So if I start from here, 1, 2, 3, 4, I'll end up having my substituents in 1, 2, and 4. If I start from the opposite direction, which is 1, 2, 3, 4, so I'll end up having my substituents as 1, 3, 4. So in naming compound, we usually give you the words to the lowest possible name. So therefore, this is definitely out. So what you have is 1, 2, 4, because 1, 2, 4 is generally words lower than 1, 3, 4. So in naming this compound, we are going to call this compound, dear brothers and sisters, whenever we see this, we call it isopropyl. But if you want to be like more specific in this isopropyl, we call it what? 1-methyl ethyl. So whenever you see isopropyl is called what? 1-methyl ethyl, or you call it isopropyl. So I'll show you why that compound here, this compound here, is called 1-methyl ethyl. So first, let's name this compound first. So in naming this compound first, I have my 1. So I'm going to name based on the green number, not by the yellow numbers. So I'm going to name this based on the green numbers. So to name this compound, I will call this was 1 isopropyl. 1. I think using the green will be more. So 1 isopropyl. What else do you have there? 4-methyl. So the green is attached to the 4. 1, 2, 3, 4. So you know, methyl come before N in alphabetical order: A, B, C, D, E, F, G, H, I, J, K, M, N. So M comes before N in alphabetical order. So therefore, methyl comes before nonyl. So therefore, we're going to call this what? 4-methyl know that this should be methane, but since this is a substituent, it's acting as a substituent, so it has one reduction of hydrogen. So we're going to call this what 4-methyl, not 4-methane. This is called 4-methyl. Now, where is this carbon atom attached? So next is what 2-nonyl. Is 2-nonyl cyclo, our parents name, which is what cyclohexane. So this is 2-nonyl cyclohexane. So since you have this compound 1 isopropyl 4-methyl 2-nonyl cyclohexane, so this is the name of this compound. So I'm going to explain this so it will not get you confused. This nonyl and this methyl. I want to emphasize something, but before I emphasize on this, let me first emphasize in this isopropyl first. So in this isopropyl, remember that I said is either you call this one, it's either you call it isopropyl or you call it 1-methyl ethyl. So the full name, whether you write it in this manner or this manner I'm going to write, both of you are also still correct. But if you want to be more specific, so you go ahead and write this thing 1,1-methyl ethyl. So an isopropyl is definitely called a methyl ethyl, 1-methyl ethyl. Okay, let me explain. Isopropyl, let's draw the structure of isopropyl. The structure, let's expand it. The structure of isopropyl is this. So what is our longest chain here? Our longest chain here is definitely propyl, which you see here 1, 2 and 3. So this is propyl. Now we have propyl. There is no substituents, so going that way is wrong. So what I'm going to do is, since my end product or my main product or what I'm expecting to get is an substituent, so what I have to do here is to call here my 1, call here my 2. So like this is just called isopropyl. So to name this compound appropriately, you just call it 1-methyl ethyl. So the full name of this compound will now be 1-methyl ethyl 4-methyl 2-nonyl cyclohexane. Now let's emphasize on let me clear some space. Now let's emphasize on these substituents, which I said the methyl and the nonyl. So you know in nonyl has this structure CH3 1 2 3 4 5 6 7 8 9. So nonyl will have this structure. So this should have ended with CH3. That should have ended with CH3, but it ended with what? CH2. So there's a reduction of one hydrogen atom. This was called, that is why we implicate that name was nonyl. It's ended with we remove one hydrogen atom in order for, you know, carbon is always in this format. It is always 4. It is always tetra. In order to obtain the octet, so carbon is 4 in the group 4 is located in the group 4. Carbon is found in group 4, so it requires more 4 covalent bonding of another compound in order to acquire 4 electrons. For it to acquire these 4 electrons and obtain the octet, so it will be balanced, so it stop reacting. So it usually bring 4 valence share for bonding, 4 covalent bonding. So this is now CH2. So why is that CH2 instead of CH3? Now let's see this diagram very well. So that should be C hydrogen with another hydrogen, which we know, but carbon now loses that hydrogen and uses that bond to this alkyl group, this cyclohexane as a parent name we are seeing here. So it loses that one hydrogen in order to bond with this, because if this hydrogen was here, it will not be possible for this carbon to bond because it is now filled. So it have obtained the octet rule. So what this carbon has to do is to remove this hydrogen. So in the process of removing this hydrogen, so since it has one reduction of hydrogen, we now call it what? An alkyl group. This is the reason why we call it an alkyl group, and we change that name from nonene ANA to YL, which is nonel, because of there is one hydrogen is out, so it uses that space in order to bond to this cyclohexane here. So I hope you have understand why we changed that name. Now, what of the methyl? If you come down and observe the methyl, the methyl methane generally have CH4. This is methane. This is methane we know. So this is methane we know. So this methane loses one and forms CH3. We now call it what? Methyl, because one hydrogen atom is out. So since one hydrogen atom is out, so this one hydrogen atom, which is what? CH3, it will now use this for bonding. So carbon we have a structure like this: hydrogen, and this is now used to bond to an alkyl group. So let me draw this so you understand. So this methyl, I'm going to clean it now. Let me expand this methyl. So expand this methyl, we now have C hydrogen, and what? Hydrogen, which is what? CH3. That's why we call this methyl. So it loses that one hydrogen in order for it to gain space and bond with this carbon here. So I hope you have understand these principles. Now let's biology students, this one look like a virus, but not actually a virus. So what if I can see this looks like one something I don't know about. So what if you're asked to name this compound? So what are you going to do to name this compound? So this question is for you. So if you get this question, you are smart, you have understand the law. If you didn't get this, so you have to just keep on practicing. So now you now have 3-cyclopentyl 3-ethyl. So the name of this compound will definitely be what? So first you're going to identify our longest continuous chain. So our longest continuous chain will be what? So our longest continuous chain, yes my students, what is the longest continuous chain? Some people say this compound, and this compound is cyclopentane, which is wrong. Some people say 1, 2, 3, 4, 5. Some people say it's 5, which is wrong. Some people also some people do something I don't know, but students who went as far as thinking that the parent name of this compound will be heptane. You are good. So this is 1, 2, 3, 4, 5, 6. So some people also do this actually. Let's check from this dimension. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So those that went from this direction and those that also went from this direction, both of you are correct. Both are for you. So this is what we call what? Heptane. The parent chain here is heptane. So since we have the parent chain, so definitely what will be this? This will definitely be a substituent. And what is that substituent? That's when it's called what? Cyclopentyl. And note that I have an ethyl group attached at my 3 carbon atom. So I also have ethyl as my substituent, and I also have a propyl group attached at 4. I also have a propyl as my substituent. Why is this propyl? As I see here, there is 1, 2, 3. So there is 3 carbon in that substituent. So you definitely call that what? A propyl. So to name this compound, propyl, ethyl, and cyclo, alphabetically, which ones come first? C come first, which is cyclo will be the first. Propyl and ethyl, which one come first in alphabetical order? E comes before P. So E will definitely come second, and P will be the last. So to name this compound, students, this is what we call tricyclopentyl 3-ethyl 4-propyl-heptane. So this is tricyclo. Why is it 3? Because it is attached to the 3rd carbon in my parent chain. And why did I call this pentyl? This should be a pentane, but we remove that AN because if you can now look at this structure, there is one reduction of hydrogen which is used to bond to this my parent chain here. So there is one reduction of hydrogen. So this one reduction of hydrogen, we now call it a pentyl group, because any compound which is corresponding with an alkane group which have a reduction of hydrogen is called an alkyl group. So we now call it a pentyl because there is one reduction of hydrogen. So this 3-cyclopentyl 3-ethyl 4-propyl because it's attached as 4. So we definitely call it 4-propyl. So this 4-propyl heptane. So our parent chain, which is what? Heptane. So the name of this compound is 3-cyclopentyl 3-ethyl 4-propyl heptane. So that is the name of this compound. 1,1-dimethyl-cyclopropane. 1,1-dimethyl-cyclopropane. So I asked to draw 1,1-dimethyl-cyclopropane. So to draw cyclopropane, propane is what? 5. So just go ahead and draw 5. And 5 is something that looks like this. Let's see 1, so any of them can be here. Just go ahead and draw this. So this is 1,1-dimethyl-cyclopropane. Now if you're asked to draw 1, 2, 3, 4 tetramethylcyclopentane. 1, 2, 3, 4 cyclopentane. So how are you going to draw this structure? So to draw 1, 2, 3, 4 tetramethylcyclopropane pentane. So to draw this structure, first draw your cyclopentane, which is this, we all know. So this is our cyclopentane. So 1, 2, 3 tetramethyl. So I'll start from anywhere I want. 1, I will write another 1, 2, I'll write another 1, 3, and I'll write another 1, 4. So this is 1, 2, 3, 4 tetramethylcyclopentane. Now what of if you have 4 isopropyl 1,1-dimethylcyclohexane.
Hey brilliant minds, this is sagacious learners where science comes alive. If you're preparing for JAMB, WAEC, NICO or GCA, or you're a 100 or medical student studying anatomy, physiology, biochemistry, physics, chemistry, or biology, then I have got something special for you. I offer private and group online lessons designed to help you understand deeply and succeed easily. Just send me a WhatsApp message on 08163207065. Don't just study hard, study smart with sagacious learners. Let's grow your mind together.
4 isopropyl one dimethylcyclohexane dimethylcyclohexane. So what of if you have this 4 isopropyl 1 dimethylcyclohexane? So if you have this, how are you going to start? First, draw your longest chain, which is hexane. So hexane has how many carbon atoms? 7. So to draw this, which how we call this? So this is cyclohexane. Let's check whether it's complete. 1 2 3 4 5 6 7. So I have 7 carbon atoms. So therefore this is called cyclohexane. So I have 4. So they said my isopropyl is attached at 4. So this is 4 isopropyl. I have 1 they said is attached as 1 dimethyl cyclohexane. So this is the structures of 4 isopropyl 1 dimethyl cyclohexane. Now what of we have to draw cyclopentane, heptane? So here is an assignment for you. So go ahead and draw cycloheptane. So this is just simple something someone else can do. So what of if you have 135 triisopropyl cyclohexane? 1,35 triisopropyl cyclohexane. So what of if you have this? Now how are you going to start? So to draw this structure, to draw 135 triisopropyl cyclohexane. So first draw your parent's name, which is cyclohexane. So this is 135. Let me draw this time. So this is 135 triisopropyl cyclohexane. So they said 1, it is attached as 1, so I'll start here as my 1. Just note you can start anywhere as your 1, but I decided to start here. They now say 3, 1 2 3 as my isopropyl. So they now also said 5, 1 2 3 4 5. So this is definitely the diagram of 135 triisopropyl cyclohexane. So what if we have 1357 tetramethyl cyclooctane? One three 5 7 tetramethyl cyclo. cyclooctane. So what of if you have this and as you draw the structural from the structural the structure of this compound? So what are you going to do to draw the structure? So they said cyclooctane. So to draw cyclooctane, we have this. First you have to draw this. So this is 1, this is 1 2 3 3 1 2 3 4 5 5 6 7. So the structure of this compound is this propane. So to draw this structure, friends name it is propane. 1 2 3, it is 3, propane is 3. They said dicyclopropyl, so mean that our substituent is attached in the 1. So I have a substituent here, cyclopropyl. So cyclopropyl is a triangle because it has one reduction of hydrogen atom, and I also have another one. How we call this? So this dicyclopropyl propane. So this 1133 tetramethylcyclobutane. So to draw this structure, cyclobutane, which we know is 4, butane is 4. So I have 4 carbon atoms, so it's 4. So they said 1 1 1 1, which is my methyl, 3 3 1 2 3 3 3 tetramethylcyclobutane. So this is the structure of this. What if you ask to draw 2 cyclobutyl 1 1 trimethyl cyclopropyl butane? As first we are going to draw butane. Butane is definitely this 4 1 2 3 4. So say 2 cyclobutyl. So I have 2 cyclo. So 2 cyclobutyl 1 1 3 trimethyl. So I have 1 1. This 3 1 2 3. And note before I start drawing again, if you just see 1 1, that's like 1 1 as a substituent. If you see a name or anywhere you see 1 1 as a substituent, that is wrong. That's like 1 1 as a substituent. 1 1 can never be a substituent unless that is a cyclo compound. If it's not a cyclo compound, if it's a normal alkyl substituent and it's at 1, it will form the parent's name. It's not going to act as a substituent. So when you're naming compound, never try naming a substituent 1. It's wrong. So this is cyclopropyl. So this is now this and this and this. Cyclopropyl what? Tricyclopropyl butane. So I also have another one here. Cyclobutyl 1 cyclopropyl 4 cyclobutyl 1 cyclopropyl 3 isopropyl 4 ethyl hexane. So first draw your hexane, which is 7. 1 2 2 3 4 5 6 7. So I have 7. I have so to name this compound, I'm going to just draw your longest chain, which is the hexane. So drawing this skeletal structure as your hexane. So you now have 4 cyclopropyl. So 1 2 3 4. I'll choose it as my 4. So I'll write it as cyclobutyl, which is this. So I'll come here and I'll write 1 cyclopropyl. So 1 cyclopropyl is this. So I'll now draw 3 isopropyl 1 2 3. So this is my isopropyl. So 4 ethyl, and I have my 4 ethyl hexane. So this is the structure of 4 cyclobutyl, 1 cyclopropyl, 3 isopropyl, 4 ethyl hexane.